inotify. It's a powerful tool in Linux that allows you to monitor file system events. So developers, system administrators, or just tech enthusiasts, or gives you a understanding. This tool, inotify, gives you a deeper insight into how operating systems manage and interact with files. So I'll look up the man pages on this. iNotify, it's monitoring file system events. It's an API. Uh, Monitors files. So you can look up the man pages on this and read this if you want. That you can put in your code to watch, to what to monitor, like different events inside of directory. So any of these events occur, it's going to log it. I mean, in me, I just printed them to a file. Which I mean, I printed it to console, but you can print them to a file. So let's okay. So these are different the libraries that you need. There's iNotify. So the one of the functions for logging, I created a logging function up here, log event. What's passed in is a pointer to a struct event. It just passes in the structure, and it so this function checks for events and prints the event. And inside this, you see event mask. This is part of the iNotify library that it's one of the includes up there. It is a field in the iNotify event structure. It indicates what kind of event occurred. Like I mentioned earlier, the event flags. So these are the different types of file system events. These are defined. You saw them in the man pages, and they're defined in the iNotify library. And I combine them to use the bitwise the pipe operator. So basically, so it looks for in create and modify and delete and all these. It looks for any of these, and it's going to print to the console. You could put this in a file if you wanted to, but I just print them to console with the standard input output library, printf. So the main function is going to look for two arguments. The first argument is the name of I call this file monitor. The second argument is going to be the name of the directory to monitor, and it's going to exit on failure if there's not two arguments at the command line. And I create a stat. I declare a stat structure, and this holds the information. This is in the POSIX library. This is going to hold information about the file or directory that's going to be monitored. So it's going to return true if the directory exists, and it is a directory. It's going to exit on failure. So this is going to output to the console the name of the directory. So this is going to initialize iNotify to monitor the file system events. So it creates an iNotify instance or exits on failure. So these are the flags I was talking about, where you add a watch to the specific directory that's given at the to when the program's running. And so these are the ones I'm looking for. There's other ones too, but these are the ones. So if any of these things happen, if a file's created, if a file's modified, if a file's deleted, if it's changed, um, it's it's gonna it's going to flag it, log it, and the way I log it is just print it to console. So I create a buffer to hold the events, and it's going to stay on as I have it set up to where as long as the command, as long as the terminal is running, this stays running. And later on, I'm going to talk about how you can keep this. You can have this start up and just run automatically when the computer's turned on, or when the computer's turned off. It's just is you can have as you can create a quick startup program with this file. So this is a buffer that holds the events and just continually monitors the events. It's going to try to read into the buffer. And this was created earlier to hold the events. It's created on the heap earlier. Um, so I create an integer I that keeps track of the current position in the event buffer. So this loops through this buffer up here to process each event. So it retrieves the current event at I and casts it to a inotify event structure. This raw data that's in the buffer must be cast to this to interpret it as because it's going to be raw data. So to make sense of that data, it has to be interpreted as an notify event structure. This interpretation allows to access the attributes of the structure, which include the mask, length, and name of the structure for processing and logging. Makes it easier to print out and log the information rather than just print it out as it is in the buffer. So there's the cast and there's the buffer created. And there's a log event function called to log the event, which is just, and then it's going to increase as the buffer, as the length, as the entire buffer. Basically, it's going to parse the entire buffer, and it's going to increase on the event size. It's just going to keep. It's going to go through the entire event buffer, and then at the end, you clean up. You remove the watch on the inotify instance, and you close the inotify instance so it frees up that memory space. And okay, so so I compile it like that. Use the C99 standard, the newer standard. Compile with GCC. It's going to the file monitor is going to be the so I can run it. Well, and so to monitor the current directory, you can go like this, which is the period. But so I'll just do this. This is the same thing, but so basically let's do that. This way, when I run it, it's going to print that out so you can see the directory. So now it's monitoring. And now I'll go over here. So this is the directory it's monitoring. It's the same directory. So let's see. So I created like new file. So input. Let's see. Let's go vim input txt. Oh, okay. So okay, now we can go back. So Vim, I open this, and Vim creates a swap file. This is the stuff that's created, and it gets deleted when I closed it. It's changed. So you see everything that happened just by opening that file. Now I could go like nano shard 256.c. So this is like this is an implementation of SHA 256. Let's just say, just go like this full loop. And I just put a comment. Just see what it does. So let's see. It created a swap file right there. Opened it, modified it. And you noticed, see how it says modified and there's no swap after it or anything? This shows that the file was actually modified. It wasn't just the swap file that gets deleted, it's the actual file. Like you could go, you can edit your code so that all these swap files aren't there, um, that aren't logged. But I just wanted to show you. So you see, this doesn't have a modified of the hello world text file. The modified's all the swap files. So that's like if you were just wanted to see if something was actually modified, you can, it would look like this. See how that was modified. So I'll go. So now the new file .txt, I'm going to delete it. Deleted the actual file. So new file, I'll put 2. So in touch, that creates a create a new file, open new file, and then the metadata. So you're actually monitoring the metadata of this directory too, which is important. So I'll go echo text for new file 2. I'll direct it to new file dot 2.txt. Open, modified. See, so let's see. It's going to show what's in the file. Okay, so okay, deleted. So you can keep track, and so it's still running. So it's just going to keep running until I close the terminal or I stop it. I can just stop it with like that. So now I'm going to describe some things that I'm going to show quickly in a PowerPoint slide how to have this as a startup file. So you can have this running and monitoring a directory whenever the computer's like turned on. And this was just to show like a demonstration of the inotify library. There's a little bit more. There's a lot more you can do with this. This is like okay. So you saw how you can create a program like a file monitor program and how to run it. But sometimes like most of the time you're not just going to when you're building the program you're going to have it like just run it and open a separate terminal and test it. But as you create a more advanced program, you may want to run it as soon as the computer starts up and have it running like in the background or running as a startup program. So I'm going to give you some ideas on these aren't the only ways to do it to run the program, but these are some things you can do. Like you saw how I ran the program. Now you add an ampersand on how I created the file monitor uh, compiled program, and this is the path. The path. Remember the path. You can put a dot right there. Um, but I put the whole path. I put pwd present working directory. Add an ampersand, and that'll run it in the background, so you can close the terminal. And also this command with the command that I had and the ampersand is going to also run it in the background, run the file in the background, and it's going to also output everything instead of just to the console. It's going to output it to this file right here. It's going to make a file. Now you can also create run it as a system service. This will run it automatically as a startup. You have to create a service file. This is the commands. Sudo, you need to have administrative privileges. Inside this service, you can call it anything you want, .service. In the service file, you're going to write all this stuff, all of it. And important is right here is what you would put at the command line right there. This is what's going to the directory that's going to be monitored at startup right there. So you write the program that the compiled name and the directory, the path to the directory, and this is what's going to with administrative privileges. That's what's going to start it up. So so I'm not going to do all that. I don't want it running on startup, and I would want to add more to the file, the program, anyways. Also, too, is you could kind of create a separate tmux session, and so this way you could just run it and open other terminals. So you just you start a new session. You do this depending on like for like opening several terminals, depending on what you're going to do for like operating systems. This is a tmux is a way to go. You could create multiple tmux sessions and have a bunch of sessions running. You can have them all on the same screen, and you could detach the session. So you could run this program and detach it, close the terminal, do other things, and then if you want to monitor it, you can reattach it right there. So this is another way to run the process in the background, but Tmux you could open a new you can create multiple Tmux sessions. Is what's good about this. Okay, so these are things you can do with as you run this program.